Okay, 21.1, parallel lines cut by a transversal. Take 2. I can determine the angles formed by parallel lines cut by a transversal. So our main key terms is transversal, a line that intersects two lines in the same place, meaning plane. So when they say in the same place, they mean like the same space. It's called a plane in geometry, not like with wings. And then at 2 different points. So they cross those lines at 2 different points. And then just a reminder, parallel lines are lines in a plane that will never intersect. So we would say they have the same slope, this kind of plane. So they have the same slope. They'd rise and run the same amount. All right, so when we have a transversal and 2 parallel lines, we have a bunch of angle relationships that happen. So in this picture, this little T right here, this is our transversal. Because if you see, it's a line in the same space as 2 other lines, cutting them in 2 different places. So basically, it's just a line that cuts 2 other lines. So parallel lines are A and B. Excuse me. And when this happens, we end up with an exterior space, so outside of my parallel lines, and an interior space inside my parallel lines. And then we have these 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. It causes 8 angles. Now these 8 angles have relationships. So the first one's called corresponding angles. They lie on the same side of the transversal, meaning they're both going to be on the right or they're both going to be on the left. Also, they're on the same side of the parallel lines. So if it's on top of A, the match is also on top of B. I like to say same side, same place. So you notice they gave us an example, angle 1 and angle 5. So if we look at angle 1, it's on the left. We look at angle 5, it's also on the left. So the first part, check. If we look, it's on top above angle or line A, and if you look here, so is 5, so that's what makes them corresponding. What's also really nice about corresponding angles is they are congruent or equal. So whatever angle 1 is, so is angle 5. So then we have alternate interior angles. So these are non-adjacent, so not next to each other, angles that lie on opposite sides of the transversal. So one's going to be on the left, the other will be on the right, or vice versa. And they are in between on the inside of A and B. So we're only talking about this space right here. So the example they gave us was 3 and 6. So if we look, 3 is on the inside, so is 6. So that part's checked. But also they have to be not touching. So 4 is touching 3, so that's why it can't work. 5 is touching 3, which means it can't work. But also 3 and 5 don't work with the fact that they have to be on opposite sides. See how they're both on the left side? So that's why this doesn't work, and 6 and 4 don't work because they're on the right side. So one's on the left, one's on the right. They're not next to each other and on the inside. What's also nice about these, they're also congruent. Alternate exterior angles lie on opposite sides of the transversal as well, just like alternate interior. But now they're on the outside of A and B. So they're in this exterior space. They're either here and here. The example they gave us was 1 and 8. So 1 outside, 8 outside, and they are also on either side of the transversal. These are also congruent. And then the last one we get is same side interior. So again, we're going to be dealing with only these angles here. And this time they do lie on the same side as the transversal, so they'll both be on the right or the left. And they gave us the example of 3 and 5. So see, inside, and they are all both on the right or left-hand side. What's nice about same side interior is if I take angle 3 and add it to angle 5, I'm going to get 180 degrees. Okay, meaning Same side interior angles are supplementary. Okay. So list all pairs of corresponding angles. So they gave us one of them, 1 and 5. We need to list the rest of them. So let's start with angle 2. So we go angle 2, it's on top and on the right. So I need an angle that's on top of B and also on the right. That is angle 6. I'm going to go slash angle 6. See, both on the right, both on top of A and B. So let's do angle 4, see if it has a match. So this one is now on the bottom, but on the right. So this match is angle 8. Okay, they already gave us 1 and 5, so then that leaves us angle 3. It's underneath and on the left, so is angle 7. Those are all corresponding angles. All right, list all pairs of alternate interior angle. They already gave us 3 and 6, so the only left pair is angle 4 and angle 5. They're the only ones left on the inside, and they're also the ones that are opposite of each other. Alternate exterior already gave us 1 and 8, so our other pair would be 2 and 7 because they're both on the outside and opposite of each other. And then list all pairs of same side interior. They already gave me angle 3 and 5, so my other set is 4 and angle 6. Alrighty. So we're going to use these relationships to find other angle measures. So it says if angle 2, we want to find angle 2, measure of angle 2, when the measure of angle 7 is 125. So this is 125. Well, the relationship between 2 and 7 is that they are alternate exterior. So that means they're congruent. So if angle 7 is 125, the measure of angle 2 is equal to 125 degrees. They're exactly the same. I don't have to do anything. All right, so then it says find the measure of angle 6 when the measure of angle 4 is 55. So if I put 55 right here, the relationship between 4 and 6 is that they are same, oop, that's not how you spell same. Same side interior. So that means they are supplementary. So I'm going to take the angle 4 and add it to angle 6 to get 180 degrees. Angle 4 is 55. Here's angle 6. So I'm going to subtract 55 from both sides. We do need to set them up like equations. We do not just do simple arithmetic anymore. And so I get that the measure of angle 6 is equal to 125 degrees. Okay, so here's our additional practice. We have angle YVW, and that's 6x right here. And we have angle ZVW, or VWZ, here in purple. And they want us to find the measure of the purple angle. This is my purple angle, okay? So the first thing we have to do is, what is the relationship between 6x and 3x? Well, these are same side interior. See, they're both on the right and they're both on the inside. So what I'm going to do is I'm going to take 6x and add it to 3x and equal it to 180 degrees because they're supplementary. So I get 9x equals 180. I divide by 9, and I get x equals 20. Now that just tells me what x is. To find the measure of the angle, I need to take my x and plug it back in. Remember, we're looking for that purple angle, and so it says it's 3x. So to find the measure of VWZ, I'm going to take 3 times 20 and get 60 degrees. There's our final answer. That is the measure of angle VWZ. Okay, so here's a practice problem for you to do. We're looking for ZWX. You're going to need to use relationships to figure out what it is. Okay, and that's the one we're looking for. Now, one of the angles you may have forgotten about, we talked about it a while ago, I think, but it was vertical angles. Vertical angles mean they're equal. Okay? So, actually I'll just do this one. So it's going to be 4x plus 5x equals 180 because these are same side interior. So I get 9x again, divide by 9, and we get x equals 20. Now if I take this and plug it in here, we get 5 times 20 equals 100. But the relationship between this angle and this angle is that they're congruent because they're vertical. And so that means the measure of angle ZWX is also 100 degrees. There are some other ways to prove that relationship, but we can talk about it next time and see if you guys can figure it out. But there's a double angle relationship that you can get there too. Okay, so things to remember, memorize. Oops. The relationships. Okay, so this is actually in your note taker, so I'm not sure again why I did that. So they want us to find GDE, BEF, and CDG. And what they did is they gave us these two angles. These two angles don't have a relationship, but I can move these around and find these relationships. So right now I know, hey, this angle, the green angle, and the blue angle, those are alternate exterior. So since this is 6x, so is this. Well, now I also know that we add this angle in, it's not actually part of it, but CDG, my blue angle, is actually corresponding to HED, which makes this 6x. Now you have same side interior angles that you can use to find x, which will then help you find your blue, purple, and green angles. Okay, until next time.